So we're asked to solve the problem 2x plus 3 equals the square root of 2x plus 1 plus 4. The plus 4 is outside the square root sign. The first thing to notice here is that this square root isn't specified as a plus or minus square root. It's left blank. What that means is by default you always assume it's a positive square root. So I'll just denote it as a positive square root. Now the first thing we're going to do to solve this is isolate the square root sign. The purpose of this is so that we can square both sides later. So if we subtract 4 from both sides, we know that the left-hand side becomes 2x minus 1, where the right-hand side is just left with the positive square root of 2x plus 1. Now before I square both sides, it's important to notice a few limitations on the domain x can have. First of all, if we look at the right-hand side, we notice no matter what's inside the brackets, as long as it's a real number, the entire right-hand side will be positive. This is because the whole square root is positive, right? So for example, if the stuff inside the bracket was, say, 50, right, no matter what the square root of 50 is, it's still going to be a positive number. If the right-hand side is positive, that means the left-hand side is positive. Consequently, we can say that 2x, and I'll write it out here, 2x minus 1 must be greater than or equal to 0. This is a limitation due to the fact that the square root is just positive. If it was a plus or minus square root, you just ignore it. We can rearrange to find x, and we can go x is greater than or equal to a half. That's just by adding 1 to both sides and then dividing by 2. We don't need to change the direction of the sign because 2 is a positive quantity. If 2 was a negative quantity, then you'd reverse the sign if you divided by it. So that's one limitation our solution will have to satisfy. X must be greater than or equal to half. For example, if we square both sides and we find out x is, equal to 3 or minus 50, for example, then we know the minus 50 solution wouldn't actually be a solution because it doesn't satisfy this constraint. So that's one constraint we know. What's another constraint we know? We also know that if we're concerned with real numbers, the stuff inside the brackets must be greater than or equal to 0. If you type into your calculator the square root of minus 1, for example, you'll get math error. That's because in the real plane, there is no answer. So we can write 2x plus 1 must be greater than or equal to 0. Right? This is another constraint. Rearranging for x, we can say that x must be greater than or equal to minus a half. So what does that mean? We seem to have two conflicting ideas of what x must be in between. Well, if we were to plot this on a number line, we'd get something which looks a little bit like this. I'll just do arbitrary numbers. Minus 3, minus 2, minus 1, 0, 1, and 2. So these are all the different values x can have. Well, according to this constraint right here, x must be greater than or equal to a half. So a half is right here, and we know x must be greater than or equal to it. So these are all the values x can seem to have. But according to this one, x must be greater than or equal to negative a half. Well, that just means that x must be greater than or equal to negative a half. And negative half is right about here, so I'll just draw an arrow there. In order for both of these inequalities to be satisfied, we need to make sure that there is a common union between them. In this case, the common union which satisfies both of these inequalities is x is greater than or equal to a half. You see that? That way both of these inequalities are satisfied. I'll do it down here. X must be greater than or equal to a half. So that inequality right there is going to be our limitation on our solution. Let's just write x must be greater than or equal to a half. So this is what's really important when it comes to our final answer. Okay, now let's go back to our original problem. Let's square both sides like we were originally planning to do. Well, the left-hand side squared just becomes 2x minus 1 squared, where the right-hand side now becomes 2x plus 1. Left-hand side expanded becomes 4x squared minus 4x plus 1. Right, this is just using FOIL method. And the right-hand side still remains 2x plus 1. Now it's crucial here to get all the terms over on the left-hand side, so we can either use the quadratic formula or we can factorize. If we do that, we can move all terms to the left-hand side, making the left-hand side equal to 4x squared minus 6x plus 0 is equal to 0, right? What I've done here is I've subtracted both sides by 2x, right? Minus 4x subtracted by 2x is minus 6x, and 1 subtracted by 1 is just 0, so I've left it blank. Righto. We could use the quadratic formula, making a is equal to 4, b is equal to minus 6, and c is equal to 0, and you'll get the same answer, but you might find it's easier to just factorize straight out. Here we notice that two common terms between these two terms are the numbers 2 and x, right? So we can factor out a 2x here. We can go 2x brackets 2x minus 3. If you don't believe me, you can re-expand the brackets and you'll get what was previously written above. 2x times 2x is 4x squared, perfect, and 2x times minus 3 is minus 6x. So we know it's about right. Now this is the interesting part. I've probably covered this in a previous video, but in case I haven't, I'll re-explain it. There are two solutions to this problem. If we were to divide both sides by 2x, right? So let me say that again. If we were to divide both sides by 2x, we would be left with the solution 2x minus 3. So I'll write this. One solution to this problem would be 2x minus 3 is equal to 0. That's if we were to divide both sides by 2x, right? Because this would become 1, and 0 divided by 2x just remains 0, right? Well, if we are rearranged to find x, we notice that x is equal to 3 on 2, right? That's one solution. Our other solution is taking the alternate path. What if we noticed that you could divide both sides by 2x minus 3, right? Well, then you'd be left with 2x times 1, right? Because 2x minus 3 divided by 2x minus 3 is just 1. So I'll just write the intermediate step, times 1 is equal, actually no, I'll write the whole thing out, just so you guys get it. 2x minus 3 is equal to 0. And if we divide both sides by 2x minus 3, this is exactly what we did with the previous one, by the way. Minus 3, I'm just writing the intermediate step, divided by 2x minus 3. Then we notice these two terms cancel, and this term just equates back to 0, because 0 divided by 2x minus 3 is just 0 again. So what we're left with is 2x is equal to 0, implying that x must be equal to 0 if you divide both sides by 2. This is not our final answer. Remember, in order for our answer to be proper, we need to make sure that all of our solutions fit inside our certain domain, which we determined before. Well, x is equal to 3 on 2 is the same as x is equal to 1.5. That's right around here. That's fine. That's inside our domain. So that's a solution. That's just fine. We know that's a solution to our problem. X is equal to 0 is not within our domain. It lies out here. That's not our domain. I'll write that in capitals so you guys know what I mean. Not in domain. So that is not a solution, right? And you may be wondering, okay, well, if that's not a solution, how did we get x equals 0 to begin with? Well, the thing is when we squared both sides, we actually essentially told the math equation that we made no differentiation between whether this was a plus or minus square root sign or just a plus square root sign. So this x is equals 0 just relates to our solution that would have existed if this was a plus or minus square root. But because it's not, there's a limitation on our solutions. As a result, x cannot equal to 0 in this particular case. You can check your solutions, just by plugging x is equal to 3 on 2 and notice it satisfies our original equation. And you can also test our solution by testing x is equal to 0 and notice it's not a solution. Alright guys, that's the answer. X is equal to 3 on 2 is our only solution. I hope you enjoyed. Bye.